This is Ham College, episode 16 for April 30th, 2016. This episode of Ham College is brought to you by ICOM. Pioneer your path. Anytime is a good time for a new ICOM base station. And by HamStudy.org, a great place to study for your amateur license exam. Good evening. Welcome to another episode of Ham College. I'm your host, Professor Thomas, along with the co-host here, Dean Martin.
Good evening, everybody.
Good evening. We've got a good show lined up tonight. We're going to cover digital modes.
Yeah, that's some fun stuff.
Yeah, it's an interesting part of the hobby that technicians can take advantage of right away.
Oh yeah. With digital modes. With analog, it's a lot of fun, but with digital modes, it just really kind of opens up basically the whole world. And we'll talk a little bit about that.
That's one of the first things Jim and I did when we got licensed was, did you ever own a TNC?
Yeah, I did.
You did? We all bought TNCs. Now you don't have to because you can just use a computer. Anytime we're shooting a show, we've got a chat room going on at the same time. It's AmateurLogic.TV/chat. Join us in there, and there's a good group of guys going, girls as well in there. I assume there's some gals in there.
I wouldn't be surprised.
There is some nights. But anyway, they're having a big time over there, and they're poking fun at us, and we're not really able to see it completely.
We're on there real time, so come join us. We can chat back and forth with you while we're shooting or in between. In between, we can do that pretty easy on AmateurLogic because we're playing a lot of videos, but here we're talking most of the show. So, but we do have a chat session at the end, so if you have questions, we take those live.
Exactly, yeah. So hang around, jump in the chat room there, and we're going to answer some questions toward the end here. We always start out by talking about whatever it was we talked about last month. What did we talk about last month, Tommy?
Well, we talked about satellites last month.
We did. We talked about, this one right here, that's a famous one.
I remember that satellite, but I do not remember the name of it off the top of my head, honestly.
Oscar. Yeah.
Should have known that one.
Yep, that was the first Oscar right there.
Yeah. They got one named Felix, too?
I don't know if they had a Felix. They're bound to have. Or if they hadn't, they're missing a good opportunity there.
I swear.
That one, I don't know. To me, it looks like a pirate's chest or something with a 2-meter antenna on it, but I don't guess that's what it is.
I'll tell you what, the most impressive thing was those little microsats we talked about. Those are very cool.
Yeah, CubeSats.
Yeah.
Yeah, those are real popular now.
Yeah, very, very cool. Inexpensive.
Yep.
And pretty neat stuff. It's amazing what you can put in a small package like that.
It really is. We like to discuss a topic on each show, besides just reading a bunch of questions and answers, and tonight's topic is going to be some of the digital modes. There's so many of them, we can't cover them all tonight, and we're going to be talking about this topic for a couple of shows anyway.
Yeah.
So tonight, I guess, to start out with the digital modes, what is one real common one, Tommy, that
probably the
use a lot?
The most common, or I don't know if it's the most common, but a lot of people use it as APRS. There's so many of them. PSK31 is another one. It's very, very common. RIDDI's very common.
Yeah.
Morse code.
Morse code is the original digital mode.
Yeah, that's the original digital mode. Then we've got there's a lot of new ones like D-Star, like we've got on some of our handy talkies.
Yeah.
That's a digital mode as well. Digital voice.
And slow scan TV.
Slow scan TV, yeah.
Pactor. There's just...
It's just so many.
Yeah,
so
it's a long list of them. There's some more popular than others.
Hellscriber.
L-Scriber, yeah.
Yeah, there's a lot, just a lot. So many, I couldn't even name all of them.
You mentioned APRS.
Yeah.
Have we got something we can show them here on APRS?
Yeah, I do. Well, APRS, you can do APRS with the radio and the TNC, but you can also do it on something as simple as your phone.
Yeah.
I think Emil demoed it with an Android phone, but we can show it on the iPhone too. There's a client for that. It's built into some handy talkies.
So what is APRS? What does that stand for, Tommy?
Automatic Packet Reporting System. And a lot of people have APRS systems set up in their vehicles, so if you go on a road trip, you can follow on the web, like on this website we've got right here, APRS.fi. There's some others as well, but you can follow along on people's road trips. So basically, generally have a GPS hooked up to it, and it sends your position. So you can see here where I was on earlier, and I checked in here from your house on my iPhone, and this is where we were, and you can see the altitude and everything. If we were moving, some of them show the speed that you're at. There's also some weather stations that check in on here that you can see the weather. You can see my D-Star node up at home there. Well, it thinks it's at home.
Yeah.
Because I have the location hard-coded in it. But that's using DPRS. It's basically D-Star position reporting system.
Yeah. So APRS, it's mostly just going to show position reporting. I mean, it's not something you go type messages in or chat back and forth.
Oh, contrary, you can do that.
Oh, you can?
You actually can do that. Now, it's a little bit difficult on the radio because they're not really geared for doing that. So you typically, a lot of the APRS radios that have the native APRS stuff built in have a keypad, and you have to basically compose your message like you used to do the old text messages before we had
beginning text message.
Yeah, the three letters for one, or three characters for one button rather.
Yeah.
And basically work out your text message like that. But you can actually do that, and it sends them, and it knows if you've checked in, it knows where you were, which iGate you were on, and it'll route that message and send it to you and come out on the air, and you can see it on your radio. It's a pretty neat technology.
So some radios have this built in and some don't?
Some don't. You can hook it up to your radio with the data port on your radio, or through the microphone connector on some.
What do you hook up?
You're going to need a TNC like we mentioned earlier, and just depends if you want to be mobile. You're going to need a GPS for your position. Otherwise, if you're stationary, you can put your coordinates in there, and then you obviously need to hook it up to the radio, and you need your computer. And you can set it up like that.
We mentioned TNC earlier. So when we first got licensed back in the early 90s, we bought TNCs, and most hams, well, I can't say most, but an awful lot of hams had TNCs back there, terminal node controllers, and that was like a modem that you could hook up between your computer and your radio. Yeah,
it was very, very popular. I think 145.10 was the frequency. See, the 10 is 010 for the backbone, where people did most of their bulletin board type stuff. So pretty cool stuff.
Yeah, and that's the same device that you can use for APRS today. It's just all in the data that it's sending.
Yeah, and the way good hams do, they were always hacking those EPROMs, which is basically the software for those TNCs. So I remember pulling the EPROM out and taking it to a buddy's house and having them burn some custom EPROM code on there. Do you remember? Did you ever do that?
I can't remember if I did or not.
Oh, yeah, it was pretty neat stuff. So I sort of hated to see that die out. Even though that was a fun facet of the hobby, it sort of got phased out. In our area, there's no traffic on that frequency at all. At least I haven't heard any.
There is some packet radio still around, and there's some people trying to bring it back, and it was a very fun and interesting mode. It's kind of slow, though, because you're relaying from one station to the next. Yeah, and there's a lot of stations all on one frequency. And
but the fact that it actually went over the air. Now I'm not a purist. I love the digital modes, and taking advantage of the internet is perfectly fine with me. I like it. I think it brings basically opens up the world. But the fact that you could do that over the air and not have to trunk anything through the web was pretty amazing.
Oh, and this technology came about way before we had a public internet too.
Yeah.
So It was, well, it was groundbreaking, really.
Yeah, it was basically amateur radio internet.
Yeah. And you can still do packet. You can do APRS from your home computer, and you don't need a TNC anymore.
Yeah, you can use a software modem, right? Software TNC. Yeah. Now, I've never used one, but I know there's some out there.
And TNC stands for Terminal Node Controller. And I didn't look this up, but I believe that's probably what that's going to mean is back in the earlier days of computers, the computer would be like a big mainframe or a mini computer or whatever, and you would have a lot of little terminals hooked up to it, and people were sharing that computer. And a terminal would be, say, just a keyboard and a monitor, and that's it. You didn't really have a microprocessor as such in there handling your computer task. You know, that was being all done over in
there are a lot of businesses that still use that infrastructure.
Yeah. But
banks, for one.
So that's what a terminal is. It's just like a monitor and a keyboard. So when they began, if that's what you were using, you had to have a modem or something to be able to connect it to the radio to send data. And also, well, we had PCs then, but sound was still in its infancy. It was just beginning on PCs. Back then, sound cards didn't come built in.
High quality sound, yeah.
Right. Well, I mean, even low quality sound, really.
Well, you had the PC speaker.
Well, the PC speaker, which you could never. I guess you could do CW with that, but so we had to have a box in between the computer and the radio. Now we can just run the audio in and out between the two. And all the terminal node controller functions are handled in software. Computers are fast enough to do it. The audio is good enough. So it kind of eliminated that piece of hardware. And that makes it real cheap to do packet or APRS or those modes today. Or a lot of different modes because you don't have to buy that extra piece of hardware. Yeah, to hook your computer.
Of course, that hardware nowadays is pretty cheap. You can go to almost any ham fest and find one for very, very inexpensive. Yeah. And if you're interested in playing around with it, it's a neat little piece of hardware to tinker with.
Well, the advantage of it too is that that TNC, the ones that we used back then, could stand alone. You wouldn't really have to have a computer attached to it if you didn't want to. You just set up as a repeater and.
Yeah, and it had its own bulletin board system built in. Yeah. As long as you didn't have it in KISS mode. Remember that?
Keep it simple, stupid.
Yeah.
Yeah.
So basically you'd have it in there, and then you basically had to have software, I think, to communicate with it. Otherwise, I forget what the other mode was called, but the thing worked as basically a bulletin board system.
All right. You mentioned DPRS a minute ago, didn't you?
Yeah, and that's through D-Star. And this little handy talkie, my ID51's got a GPS built into it, and you can use it to report your position back as well. So I've got I don't think my cable's too short here, but I've got my DHAP here, my DV Mega inside of this little DHAP box. This is the software that's running on my Raspberry Pi. It's the same one you would use if you made your own D-Star hotspot. With the D-Star handy talkie, they don't really have the typical APRS built into it, but they have DPRS. There's a GPS built into the top of this thing, and once it gets the GPS signal, when we transmit, the D-Star repeater will pick it up. And if we flip over, I'll show you my little hotspot here. We transmit, you can see my call sign over on the side, and on the right of this other screen right here, you can see I've got DPRS enabled on here, so it'll take my position from the GPS.
It's built into that radio,
and send it out into the APRS network, and then that can be tracked on the same site that we showed earlier.
And some of the D-Star rigs have the GPS built in it. Some you would have to add a separate GPS.
Most of the newer ones have it.
This is a screenshot from the front of my IC7700 here. It has PSK31 and RTTY decoder and encoder already built in the radio. Most don't have that, but this particular one does. You can see where there's, there was a CQ right there from
K8 EAC.
K8 EAC, yeah. Please copy. Apparently nobody copied because nobody answered there. You see all that above that, that's all what you term garble.
Yeah.
That's just random noise that's coming in. If you look over on the right-hand side there, you can see some signals right there, and the way we would operate is we would peak on top of one of those signals. Now, you don't have to have all this fancy interface. Well, here goes somebody else here.
AD0BK.
Yep, he's calling CQ. If we had a keyboard sitting here with us, we could answer him and do a PSK31 transmission right here. You know, I'll have a Q cell.
Yeah, so you don't have to have a radio with this built in it, though.
No.
You can have a simple
HF
radio and hook it up to your computer. You may need an interface box depending on your radio, but if you've got one of the newer ICOM, the modern ICOM radios, that stuff's built in. But they don't all have that. But
no, typically you wouldn't. You and it's very simple. You're just connecting the mic and speaker of the rig to your computer.
Right.
And you and I have built a lot of interfaces before. It's the same thing you could use for connecting Echolink to a radio, or
you can make one for about $10 worth of parts, or you can get like a SignalLink, SignalLink USB or something like that. Also,
if you want
to do it, if you
don't want to build it yourself.
Right.
But we've actually covered it on AmateurLogic before, and if you go back and search, you'll.
Yeah, it's an easy, fun project too, so I recommend doing that.
It is. So there's PSK31. That's a really popular mode now. Apparently AD0BK's, I don't know, we're hearing him good here. It's a shame we're not answering, but we're kind of tied up at the moment.
Yeah, and I was a little hesitant about showing this because I thought that this was only done on HF, but there's actually a frequency set aside for 2 meters to do this as well.
Really?
144.144, I believe, is what it showed when I looked it up on the chart earlier.
Huh.
So I wasn't aware of that. I'm going to have to listen for it, see if anybody around here is doing it.
Well, is there any more digital modes we wanted to talk about before we get on into the question?
We can talk about some digital voice for a second if you want to, since we got the D-Star stuff handy. That's a digital mode as well.
Well, yeah, I guess it is.
It's digital, and it's pretty neat. Obviously, if you watch AmateurLogic, I'm pretty fond of it because of my travels. It's a nice way to take basically a repeater with you and talk all over the world. We can use digital technology and take advantage of our DV Mega here.
Yeah.
And I have a DVAP as well, so that's why I said that earlier. But at any rate, you can use this and connect to repeaters and reflectors and talk to people all over the world from just about anywhere you've got an internet connection.
Yeah, but you don't have to have this box if you've got a D-Star repeater in the area.
If you have a D-Star repeater, that's right. Yeah. You don't have to. You can use the repeater.
And Yaesu has a system out called System Fusion that's new. And I don't think it will allow you to connect. Well, maybe. I just don't know that much about it, but it's not quite as developed yet.
Yeah, it's kind of new. Yeah. I think you can use a similar device to this and connect to reflectors. Maybe I haven't ever used it, but I know there's some capability there. I just don't know enough details about it.
And then there's a lot of voice over internet protocol systems out there. I don't know if I would call them digital because they're using a computer, and it does get down to bits sooner or later. Echolink, IRLP, those are
Echolink's very
popular technologies as well.
Oh yeah, we have nets on Echolink all the time. I know the Ham Nation has an Echolink net every week.
They do, yeah. And we used to have a good many of them, and we occasionally get on Echolink after a show and chat a little bit.
Yep, definitely. So digital's fun.
It is. It's not terribly difficult to get started in either.
No, it's not difficult, and it's really not expensive.
No,
for the most part. If you have, pretty much everybody's got a computer.
If you've got mic fright, digital is a great way to get started.
That is the way to go for sure.
Yeah, because you can get right on and start having some activities without worrying about talking into a microphone.
Yep, definitely.
Well, Tommy, let's take a break for just a moment, come back and get into our questions and answers for tonight.
All righty.
Pioneer your path. Anytime is a good time for a new ICOM base station, Be one of the first to experience how ICOM is changing the way receivers are designed with ICOM's new IC7300. It will exceed expectations. It has RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. With ICOM's IC7851, when running with the big dogs, you'll be the leader of the pack with all the pile-up breaking, frequency running tools at your fingertips. 1.2 kHz optimum roofing filters, new local oscillator design with improved phase noise, several spectrum scope enhancements, and more. Other worthy candidates that cannot be overlooked: ICOM's IC7600 and IC7700. These radios feature LED backlighting on an ultra-wide 5.8-inch display, advanced DSP technology and 3 roofing filters, spectrum waterfall display on an impressive 7-inch color LCD, audioscope function for AF observation, and direct remote control operation with ICOM's RSBA1 software. Visit ICOMAmerica.com/amateur for more information on ICOM's base station radios. Okay, Tommy, we've got a lot of fun questions here tonight if you're into digital.
Yeah, you know, before we move on to the questions, I was just going to bring up something. I saw Arnie mention something in the chat room, and I meant to bring it up earlier and forgot, but you can also use software or even some hardware to decode CW, so you don't even have to learn Morse code anymore. You can actually use a keyboard.
And I have done that and gotten a QSO with one of my friends one night that I had not talked to in a long time. And
do you tell him you got really proficient with the code?
I didn't tell him that. He was thinking that I must have until finally I told him what I was doing, and he said, okay, that explains it. But, that works pretty good. I mean, I don't, some stuff will slip past it, and you know, it might not decode it. It always encodes perfectly though.
Yeah, I'm planning on doing at least I want to, if I can find all the right stuff. I want to build a CW decoder out of an Arduino.
Well, I do too, and I've got some of the software to do it with. I have not been able to make it work.
So whoever gets there first, I guess you'll see that on Amateur Logic.
I guess so. Yep.
So anyway, it'd be a fun project to do.
All right, well, let's get on into the questions for tonight. And before we do that, why don't we give away something? You know, we'd like to give away
what about one of these?
A prize every now and then.
There you go. Here.
There's the perfect thing to give away.
It is.
A perfect 2 things.
An ICOM wardrobe.
Yep. The ICOM hat.
ICOM cap. And another ICOM t-shirt that looks very similar to the one we gave away last month about this time.
Well, the wrinkles are in the same place and everything.
They are.
As a matter of fact,
It's a nice shirt, good heavy-duty shirt. You'll be the best looking one. You and the people with the Amateur Logic swag.
Yep.
Or Ham College
swag.
Yep. So let's give this away to somebody.
All right. So the way we do it is we just have a random drawing. You send us an email, hamcollege@AmateurLogic.TV, and we just pick a random number with a random number generator, and whoever number comes up, they win. And our lucky winner for April is Paul Hyland, NG0P. Congrats, Paul.
All right. Congrats, Paul.
ICOM.
Yep. You're going to be looking sharp at the Ham Fest, you and the people with the Amateur Logic and the Ham College swag.
Yeah. And if you want to win one of these, we'll drop us an email to hamcollege@AmateurLogic.TV. You might be next month's lucky winner.
Yeah, it worked for Paul.
Yeah, do it. I mean, seriously, make yourself a note if you're too busy in the chat room to get over there right now. But somebody's going to win.
Yep, absolutely.
Yep. All right, well, let's get on.
What about, speaking of ICOM, you know how we did the live show from the ICOM booth at Dayton last year?
Yep.
Well, we're going to do another show from Dayton. Maybe 2.
Maybe 2. We haven't decided. We're going to do 2 hours worth of recorded live before a studio audience.
Yeah, unfortunately, we won't be able to stream it because they're having some bandwidth issues there, I guess, this year. The satellite company's not going to be providing the bandwidth again, I think, right?
Right, they won't be providing it this year. So we're still going to, from our perspective, it'll be the same. We're going to be having a show there with a bunch of friends. And
yeah, so come on by and see us and watch the social media. We'll post the time that you can come by. If it's going to be 1 or 2 shows, I'm not sure yet, but still in development stages, but it should be a lot of fun.
Yeah, so Amateur Logic live from the ICOM booth in Dayton again.
Yeah.
Yep.
We'll be live.
We will. Well, we'll bring back, we'll record it just for you guys, and we'll let you know where to watch it once it's posted. Well, Tommy, let's get on into our emails for tonight. And
well, how about some questions? Instead of doing some emails.
Yeah, since we don't really do emails.
I did get an email.
Yeah, let's do that
email tonight. I thought it was interesting. Came from.
Oh, you got an email there, Tommy?
I do have an email.
Yeah.
And it's not from email.
Oh, it's not.
No, it's from Richard. Rich, K9QLQ, and Serena, KD9FXN. It says, George and Tommy, I'd first like to send a thank you to the AOTV crew. I truly appreciate the work you guys have put into producing a fun, entertaining, and informative program by giving back to the ham community as our video Elmers. After several episodes of Ham College and Gordo's book, my fiance took her technician class exam at our monthly local VE test session and passed. Thanks again, guys. The simple hands-on electronics theory and history are a great way to tie into the exam element review. We hope to see you guys in Dayton. To thank you personally, 73 Rich, N9QLQ, and Serena, KD9FXN.
Yeah, congrats,
sent from his
Serena.
Atari 2600.
Oh, really?
That's what it says at the bottom right there.
Cool.
Awesome.
Yeah.
But anyway, I don't really think of us as Elmers, but I guess some people might. But we're glad that it motivated you to get your ticket, and look forward to meeting you at Dayton.
Yeah, looking forward to it. Well, let's get on into the questions and answers here, Tommy, see if we can help make a few more hams.
Let's do that.
All right, the first one here. Which of the following is an example of a digital communications method? A, packet.
B, PSK31.
C, MFSK.
Or D, all of these choices are correct. And I know A, packet is a valid answer because we've done that.
Yep.
And just discussed it actually. B, PSK31. Well, we just saw that with our very own eyes.
And we've done that too.
We've done that too. C, MFSK. I have not done that. But I do know A and B are correct, and I'm assuming C is. D, all of these choices are correct, has to be the correct answer.
Well, I think you're right, and I kind of agree with your logic there. You know, at least 2 of those are absolutely true, packet and PSK31. Even if you've never heard of MFSK, you know, I would be with you. I'd choose D. All these are correct. So let's see how we turned out on that.
Bingo.
Bingo.
And it looks like everybody in the
give it
chat.
up. Everybody over in the chat room, said D as well. So far, so good. Well, let's go on to the next one.
All right. What does the term APRS mean? A, Automatic Packet Reporting System.
B, Associated Public Radio Station.
C, Auto Planning Radio Setup.
Or D, Advanced Polar Radio System. And it's my turn to answer?
It is your turn.
All right. Well, Tommy, I'm going to have to say, I know it's not Associated Public Radio Station. Auto Planning Radio Setup, I've never heard as such. D, Advanced Polar Radio System. No, I've never heard of that either. The one that sounds most like it might be amateur radio to me is Automatic Packet Reporting System, not Automatic Position Reporting System.
That's correct.
That's correct. So I'm going to say it's A.
Although, that's really not what it means, but it could really easily fit for what people use it for. It could fit. It's not the right answer, but but I could see how it could be.
Yeah. So what's everybody saying over in the chat room? Well,
A.
Mike says it's D in Canada. Well, maybe so. But this is an FCC exam. So what do you think, Tommy? I'm going to go with A.
It's A. Going with A.
There you go.
Seeing how just made 15 minutes of bloopers over that same thing.
Yeah. Okay, on with the next one. Which of the following devices provides data to the transmitter when sending automatic position reports from a mobile amateur radio station?
Oh, it's a mouthful.
It's A, the vehicle speedometer.
B, a WWV receiver.
C, a connection to a broadcast FM subcarrier receiver.
Or D, a global positioning system receiver. It's kind of hard for me to see that one for some reason.
Yeah.
Okay, so I get to answer. So it is not going to be the vehicle speedometer.
No.
Although speed does come in the packet sometimes, the telemetry that comes from it. A WWV receiver? No. Connection to a broadcast FM subcarrier receiver? That doesn't even make any sense to me, so I'm going with D. I think it's going to be a GPS receiver, a global positioning system receiver.
Well, everyone in the chat room's agreeing with you except for one there who's saying it's definitely A. Well,
but I think he's pulling somebody's leg.
I think he must be. So I'm going to go with you, Tommy. I think it's D.
Gotta be.
Let's see. There you go.
Fist bump on that one or what? All right.
Yeah, might as well.
All right, we'll do that a few more times.
Okay. Well, let's see what we got next here. This is yours to read.
Okay. I catch myself checking out the chat room.
Well, I did too, yeah.
Which of the following is an application of APRS, or Automatic Packet Reporting System? A, providing real-time tactical digital communications in conjunction with a map showing the location of stations.
B, showing automatically the number of packets transmitted via PACTOR during a specific time interval.
C, providing voice over internet connection between repeaters.
Or D, providing information on the number of stations signed into a repeater. Okay, well, I think this one we should probably be able to reason it out pretty easily. Which of the following is an application of APRS? D, providing information on the number of stations signed into a repeater. No, I don't think it's got anything to do with a repeater really. C, providing voice over internet connection between repeaters. No. B, showing automatically the number of packets transmitted via PACTOR during a specific time interval. No. I've never used PACTOR. I know that's another mode.
Mm-hmm.
I'm going to go with A, providing real-time tactical digital communications in conjunction with a map showing the location of stations. And the question was, which of the following is an application of APRS, not the application.
Mm-hmm.
So it doesn't have to be tactical, but in this case, yeah, that makes sense. Since we know that it reports your position. I'm going to go with A, just like everyone else in the chat room there. And
yep.
Congratulations to me.
Congratulations
and
to you.
Everyone in the chat room.
Yeah, and that brings up an interesting thought about real-time tactical digital communications. That one of the things that is useful for that is like search and rescue type things, and I know that, and that is D-Star as well. The GPS functionality in here, that's a big thing that can be used for. But I'm kind of wondering if anybody knows of any situations where people have used APRS or the GPS and D-Star or something like that for any type of search and rescue operation.
Oh, I'm sure there has been.
Yeah, I'd just be interested to hear of it. I'm sure there are. You don't really read about that very often, so just kind of it's an interesting topic and a great application for the technology.
Oh yeah, perfect application for it. Next question here: which of the following may be included in packet transmissions? A checksum which permits error detection.
B, a header which contains the call sign of the station to which the information is being sent.
C, automatic repeat request in case of error.
Or D, all of these choices are correct. Okay, so me being the computer nerd that I am, a checksum That's totally plausible. So that basically does some math and tells you that the data is correct that's contained in the packet. That's totally plausible. A header which contains the call sign of the station that was being sent, yeah, that sounds totally necessary so that it can be sent to the right place. Automatic repeat request in case of error, that seems like a good thing to have too. So I'm
if you're going to have a checksum,
yeah, why wouldn't you?
Yeah.
So D, all of these choices are correct, is going to be my final answer.
Well, I'm going to go with you, and so is the chat room. There you go. All these choices are correct.
Nailed it.
You know, I believe these people over here in the chat room are about ready to go take their test.
They should.
They're doing pretty good.
Yeah, looks like most of them have already taken it.
Yep.
You may want to take it again.
Yeah, you're good at it. What we got next, Tommy? Yeah.
What code is used when sending CW in the amateur bands? A, Baudot.
B, Hamming.
C, International Morse.
Or D, Gray. And this is mine to answer.
This is all yours.
Okay. What code is used when sending CW? Well, we know Baudot is another digital mode. Hamming, I'm not sure about that. Is that even a mode?
No, not that I know of. It's just what we do.
Just what we do. C, International Morse. Well, I know that's a Morse code, and we do use Morse code. Gray, I believe Gray may be another...
I've never heard of that one, but it's totally possible.
But I know there's an American, and we don't use that in amateur radio. So I'm going to say it's C, International Morse, along with everybody else over in the chat room.
I concur.
There you go, International Morse.
International.
All right, well, next question here. Which of the following can be used to transmit CW in the amateur bands? A, a straight key.
B, electronic keyer.
C, a computer keyboard.
Or D, all of these choices are correct. Well, a straight key, used to have one sitting over here.
We did have one. This is a straight key.
Yep. So I'm pretty sure that can be used. An electronic keyer, we talked about that earlier, didn't we?
No, I don't think so.
Electronic? Would that be a paddle?
No, that would be, I would think, well, a memory keyer, but I may be wrong on the exact terms on that.
Okay. Well, I know a keyboard can be used. So I think the answer is going to be D. All of these choices are correct.
Well, me and everyone else over in the chat room think so too. And Charles says it's .dit.
Yep.
So
he's right.
Yep. All these choices
he used
are
his
correct.
Keyboard.
He did.
That's correct right there. He just proved it.
It was a novel use of the keyboard too.
Right, and timely.
Yeah, timely. Speaking of timely, why don't you and I take time out for just a moment, come back, I'll have some new questions loaded up here, and
we'll turn the air
we'll roll with them. Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at HamStudy.org. HamStudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebean, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, HamStudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit HamStudy.org on your desktop computer or mobile device. Register for a free account at HamStudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive matter. Check out HamStudy.org, powered by ICOM, for free learning tools. Good luck on your next exam. Well, let's get on back into some more questions here. Okay. We got a few more to go.
What is an ARQ transmission system? A special transmission format limited to video signals.
B, a system used to encrypt command signals to an amateur radio satellite.
C, a digital scheme whereby the receiving station detects errors and sends a request to the sending station to retransmit the information.
Or D, a method of compressing the data in a message so more information can be sent in a shorter time. And Tommy, this is the one that I wanted you to have to answer. It didn't come up that way, but why don't you take a stab at it?
Well, ARQ, I'm going to guess that it's going to be C, where a digital scheme where the receiving station detects errors and sends a request to the sending station to retransmit the information. I honestly don't know if that's correct or not. Just by reading the four things as we just went down through them, I'm thinking that's the right one.
Well, everybody in the chat room thinks it's a C. And now I feel bad because when I was typing all these in,
you got it wrong.
I got it wrong. I just really didn't know.
Which one did you think it was?
I don't even remember now, but I just remember getting it wrong.
Just when you wasn't C. Huh?
Yep.
Method of compression. ARQ, automatic request. That's what I don't know.
Yeah. Well, let's see what you say. Yep. It's correct.
All right.
C. I don't know how I missed that, but I did.
And I don't really know how to reason that out other than ARQ looks like automatic request, like abbreviated.
Yeah. Yep.
Or an acronym, sort of.
Yeah, Mike says ACK, A-C-K, which is...
that's acknowledgement.
That would be right the opposite.
Mm-hmm. That's just basically saying that you received it. Everything's okay.
Yeah, you did receive it. Send me the next. Mm-hmm. Okay, well, let's go on to the next question here.
Let me read it again?
Yeah, why don't you read it again and I'll answer this time.
What may occur if data signals propagate over multiple paths? A, transmission rates can be increased by a factor equal to the number of separate paths observed.
B, transmission rates can be decreased by a factor equal to the number of separate paths observed.
C, no significant changes will occur if the signals are transmitting using FM.
Or D, error rates are likely to increase. Well, I think this
know that one.
Yeah,
that one's pretty straightforward.
This is pretty easy to answer here. What may occur if data signals propagate over multiple paths? If all those data signals are on the same frequency, which I'm assuming they are, transmission rates certainly won't increase. I'm thinking I'm going to be, having problems picking up the signal. So it's not going to be A. B, transmission rates must be decreased by a factor equal to the number of separate paths observed. How would you know how many paths a signal was being propagated over? No, you wouldn't.
You'd have to do some math on your transmission rate.
I guess so. C, no significant changes will occur if the signals are transmitted using FM. No, I don't think that's correct either. If your signal is being propagated over multiple paths, like in the case of multipath, I'm going to say it's D, error rates are likely to increase.
I would agree with that.
And that's what everybody's saying over in the chat room, so there, we all got that one right.
You're going to have packet problems if you get multipath and timing errors.
Yeah, you're going to be using that ARQ signal there quite a bit, aren't you?
Yeah, you're going to give that a good workout.
Yeah. Okay, next question here. Which of the following would be connected between a transceiver and computer in a packet radio station? A transmatch.
B, a mixer.
C, a terminal node controller.
Or D, an antenna.
Oh, what do you think?
Okay, which of the following would be connected between the computer and the transceiver.
Mm-hmm.
It's not transmatch, and it's not going to be a mixer. We discussed this earlier. It's basically going to be the device that's going to be like a modem.
Mm-hmm.
That's going to take the signal over the air and turn it into something digital that the computer can read, some ASCII or whatever, or binary if you're doing a transfer. So I'm going to say that it's going to be C, a terminal node controller, which is essentially the name for a modem.
Well, I'm going to go with you too, and everybody else is saying it's a C. And yeah, terminal node controller. You know, that question is maybe a little bit.
At my house, it would be USB cable.
Yeah, that's what I was going to say.
But USB cable wasn't up there, and that's not only for...
Because our terminal node controllers are in software most of the time now.
Mm-hmm.
So, I mean, you can still use an external one, and that would be the choice out of those right there. You wouldn't put a transmatch between a transceiver and a computer or a mixer or an antenna. So you only got terminal node controller left.
You could put a mixer in between the transceiver and the computer, but not for digital. Well, typically not for a digital mode.
No. I mean, yeah, I guess you could, but
you'd have the audio.
Yeah.
Right there.
As a matter of fact, that's normally the way I do it. Is or have done it in the past. I do have a mixer in there, but I mean that's not. But pay no attention to what I just said there. That's not necessary.
There's exceptions to almost everything.
Yep. Okay. Next question.
How is a computer's sound card used when conducting digital communications using a computer? A, the sound card communicates between the computer CPU and the video display.
B, the sound card records the audio frequency for video display.
C, the sound card provides audio to the microphone input and converts received audio to digital form.
Or D, all of these choices are correct. Well, let's go back over them. How is a computer sound card used when conducting digital communications using a computer? A sound card communicates between the computer CPU and the video display. Now, sound is audio. It wouldn't have anything to do with video. So we know that's not right. B, the sound card records the audio frequency for video display. No, we don't really need to display the audio frequency on a video display. C, the sound card provides audio to the microphone input and converts received audio to digital form. That's it right there. You know, before when we were using terminal node controllers, that's basically was their job. But we can do it all in software now for a sound card. And we know since A and B are wrong, that all these choices are correct is not correct.
Yep, no need to go any farther.
Nope. Okay, well, we'll see what we got here. Everybody else says it's C, and it is C. Okay, now let's switch over and have a few electronics questions here. We'll just change topics for a couple of minutes. We'll get back to more digital next show.
Okay. Which term describes the rate at which electrical energy is used? A, resistance.
B, current.
C, power.
Or D, voltage. Okay, this is mine to answer. Which term describes the rate at which electrical energy is used? Resistance is an impediment to electricity. So it's not that. B, current. Well, you would think that I mean, there's current involved in it, as well as B, there's voltage involved in it. But if you add the two together, voltage and current, you come out with power. C right there. And here's a way you can think of it. It's asking what describes the rate at which electrical energy is used. Think about the electrical meter on your house. And what does it read out in? It reads out in kilowatt hours.
Mm-hmm.
And what is the unit of measurement for power? It's a watt. So
yeah, so why is it watt up there?
Because it's power. Power is measured in watts. That's the unit of it. So I'm going to say it's C.
Okay.
You see what I'm saying?
Yep.
Okay. There we go.
Nailed it.
Nailed it. Okay, next one. Electrical power is measured in which of the following units? A, well, I gave this one away, didn't I? Volts.
B, watts.
C, ohms.
D, amperes.
And that wasn't intentional. I just...
Wow.
Yeah.
Let me think a little while on this one.
You better study this one hard.
I'm going to guess it's B, watts.
Well, I think you're right, and there's...
It's pretty hard to miss that one.
Yeah. And you really can't, use the same thinking process I used before, electrical power. How do you measure it? You know?
Yeah, it's exactly the same question. You just got two words that are almost synonymous for each other.
Yep. One's what it actually is, and the other is the units that you measure it in. So, yeah, I'm going to go with you. It's going to be B. There you go.
All right.
B. All right. What have we got next?
What is the formula used to calculate electrical power in a DC circuit? A, power equals voltage multiplied by current.
B, power equals voltage, E, divided by current, I.
Oh, you're saying no. Okay. C, power, P, equals voltage, E, minus current, I.
Mm-hmm. Or D, power, P, equals voltage, E, plus current, I. Well, you just kind of have to know the formula for this. And it's going to be A, power, which is P, is equal to the voltage multiplied by the current. That's the formula, P equals I times E. You're multiplying the voltage and the current together to get the power. I don't know how else to tell you to remember that one. That's one of those formulas you need to memorize. All right, everybody's saying A over there in the chat.
I think everybody's right.
I think everybody's right too. Okay, one more here. How much power is being used in a circuit when the applied voltage is 13.8 volts DC and the current is 10 amperes? A, 138 watts.
B, 0.7 watts.
C, 23.8 watts.
Or D, 3.8 watts. Well, using the formula that you just said, same exact thing, right?
How much power is being applied in the circuit?
Yeah.
Yeah, and they give you the voltage and current.
13.8 volts times 10 amperes. I'm going to say it's 138 watts, A.
I'll say that's very good logic there, and everyone else agrees with you. 138 watts.
All right.
Okay, and one final question for tonight, Tommy.
How much power is being used in a circuit when the applied voltage is 12 volts DC and the current is 2.5 amperes? I'm sorry, I was already figuring it out. A, 4.8 watts.
B, 30 watts.
C, 14.5 watts.
Or D, 0.08 watts.
0.208 watts.
Yeah. What did I say?
0.08. You left off the 2.
Well, I did, and I'm wearing the glasses too.
Need another pair?
0.208 watts.
Okay.
Okay, how much power is being used in a circuit? They give me the voltage. They're saying 12 volts times 2.5 amps. And I'm calculating it here. I say 12 times 2.5. And that comes up to 30. So 30 watts.
You nailed it.
That's what everybody else is saying too, so they said I nailed it. And they were right. So those are a couple of, or a few easy questions there dealing with power.
Yeah. These were easy. All we had to do was times, as we didn't have to do any gazentas this time.
Yep. The gazentas are a little more difficult.
Yeah, maybe next month we'll have some gazentas.
Yeah, and you can use a calculator on your exam. It just can't be one that can store the formulas in there.
Yeah, no programmable calculator. Can you use I don't remember if you can use a cell phone. I don't think you can use a cell phone calculator either. I don't remember anybody using it.
Yeah, I'm not sure. I was going to say I did when I took my exam for general and extra, but I don't think.
Yeah, because you can put notes in there pretty easy.
Well, I don't think the cell phones we had then were.
Way back then?
Yeah.
Did we even have cell phones then?
I think we had cell phones.
Okay.
Yeah.
Yeah, no phones. That's what I was thinking.
Yeah. Okay. Well, there you go. Some questions on digital modes and some on power as well.
Yep.
For tonight. We'll have more digital modes next month. And I'm not sure what else we'll have in addition to that.
There's no telling.
It's no telling. Well, let's come back in just a moment, visit with chat room for a few minutes before we go.
Okay.
On the 15th of each month, ICOM is proud to sponsor AmateurLogic.TV with hosts George Thomas, Tommy Martin, and Peter Barrett. This looks a little crude, but roughly here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
Actually turn that into a scanner capable of tuning across a wide range of frequencies.
Whoa, okay.
What is this called?
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas via the switching matrix.
Down in Melbourne, apparently they tune up their radios different than we do, Tommy.
Oh, yeah?
Now, the FM 900 is tough. Seriously tough.
We finally arrived.
Man, we were in Ham Nirvana.
Again. Boy, what a great time. And as happened last year, we still haven't got all the way through the flea market yet.
No, we've hit about a fourth of it, but we're going to have to strike a trot.
Well, the moment of truth has arrived. I've attached a B&C connector to the antenna terminals here. I've got plus 12 volt and ground power coming in here. It's going to my power supply. That I'm supplying it with 13.8 volts.
And I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
Yeah,
what about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack, and went outside. The house lost power. And the whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow. That explains a lot.
All right, Tommy, sing the theme song here. A memorable moment from Amateur Logic, or a few memorable moments there.
Yeah, like you were saying, that one about Emil in the Super Bowl. Some people may not even remember that by now, but the power went out through part of the Super Bowl, and that's what we were referring to.
Yeah.
But it was pretty funny at the time.
Well, let's visit in the chat room here for a few moments. You know, we were mentioning about did we even have cell phone calculators when we took our exam. Yeah, I think we did. I don't think we had iPhones, so I don't remember.
Yeah, did you see what Hammer said in here?
Yeah.
Hammer USN said back when we took ours, phones still had wires. that is true. I probably still had a wall phone in my kitchen back then.
Yeah. Well, I got a phone up here with wires on it.
Really? I don't even have one anymore.
You don't? I got one with wires and IP, both.
Yeah, although I do wish sometimes I had one I could plug a fax machine into. Occasionally, once a year, maybe I need to fax something.
Yeah, well, you can come over here if you need to.
Well, I may take you up on that.
By the way, Hammer USN is studying right now to take his exam.
Oh, awesome.
So we want to encourage him to to get on through your study material there and go get licensed.
Yep.
You know, join us on the air.
Came to the right place, Hammer.
Yep. Well, what's going on else in the chat room? A whole lot. They've been real active tonight.
Yeah, it has been really busy.
Yep.
Ohm's law is a law that can't be broken, isn't it? That's true. You can't break it.
No.
It just is.
Yep. It's not just a good idea.
It's the law. That's what, yeah, that's in here also.
Yeah.
Mike KJ.
Mike says in Canada, can't use programmable calculators or ones that can store formulas.
Yeah, and I had mentioned about wasn't sure about the phones, but you can't use a phone in there. This calculator on the phone.
So I could not use my Radio Shack pocket computer that I had written the basic program in to solve the variations of Ohm's law for the test.
Yeah.
You could use a slide rule, I think. I haven't seen any mention of that.
Yeah, slide rule's good.
Yep.
You just can't use anything that you might possibly could cheat with.
Yep.
No iPad, phone, anything like that. Paul, W2PND, says we inspired him to study after watching our show, and he passed TX and G same day, but I think he means technician. In general. Same day. So that's great. Two in one day. That's quite the accomplishment.
Yeah. Congrats, Paul.
Yeah.
And that's great, but don't let that discourage anyone out there. If you just take your technician exam and that's the only one you pass that day, congratulations. That's, you've just gotten licensed. If you're a technician and you pass your general, but not the extra, congratulations. You just added to your privileges.
Yep.
Enjoy what you got. You don't have to.
Yeah, it's no race.
Go straight from ground zero to 100 miles an hour in one sitting. That's
Although
great.
I wanted to.
That's a good accomplishment, but you'll still have a lot of fun, if you upgrade one step at a time. There's a lot to be enjoyed in between those, because you and I went from technician to general and extra in how many years?
A lot.
Yeah, it wasn't quite 20.
It was well over 10 years.
Yeah.
Can you take the test that date? You most certainly can, Hammer.
Definitely. We've administered some of those tests.
Yeah, we did. The first time we went out there together, which would have been my second time out there, we volunteered to work a VE session.
Yeah. And
there's quite a crowd there. So if you're going to go, get in the line early.
Yeah.
And so you can go. But that's they have quite the operation there for that.
And if you're volunteer examiner, I'm sure they would love for you to help administer some of those exams.
Oh yeah, I'm sure.
Hamvention.org.
Yeah, but there's got to be some information on there about it.
Yep.
All right. Well, 73, everybody.
Yep.
We will see you in a few weeks for Amateur Logic.
Yeah, we will. And be making your plans now for Dayton. It's not far away, and hotel rooms are getting hard to find.
Yeah, hopefully when we shoot the next Amateur Logic, we'll have more details about the live show that we'll be doing there.
Yeah, but it won't be streamed live. It'll be recorded before a live audience. So
73.
73. What does it stand for?
Automatic Pack Position Reporting System, I think it is. No?
I don't know. I mean, we should probably know that because use a computer, but yeah, we'll talk more about that.
When the lights come back on.
Yeah. Well, it got dark in here all of a sudden, didn't it?
What happened?
Do you know which one that is?
I'll tell you when this, whatever you got flying around here quits buzzing around my head. Actually, There's something flying around in here. No kidding.
Really?
Yeah. Well, yeah. Well, I didn't know we were going to. So it's not in the script.
No. So what about this APRS, Tommy? What does that stand for?
Automatic position and transmit. Put it back.
Well,
Well,
yeah, there was another digital mode we were going to briefly touch on here, and that's not it. That's Oscar.
yeah, I know that now.
What do you think?
Well, I think somebody didn't format their memory. It stands for automatic packet reporting.